Ah, vacation. Nothing like a little time off to clear your head, do a little bit of hiking, and get off of your shift work schedule and back to a normal sleep schedule. Right? We're getting back to a normal sleep schedule this time?
At least 5 severe solar storms could be directed toward Earth.
That for the first time in about 20 years, a level G4 has not been issued since 2005.
Colorful auroras as far south as Alabama.
Rare occurrence.
Okay, fine. Nocturnal it is. If we're dealing with what might have been the greatest geomagnetic storm of the century, I better go through and explain how auroras work anyway. Okay, so here's the sun. What you're looking at right now is a solar prominence. You might have been able to see one of these on the eastern limb of the sun during the 2024 solar eclipse. We're able to see these images thanks to the Solar Dynamics Observatory, a satellite that's up in space constantly monitoring and mapping out the dynamics of the sun itself. We do this partly because the sun sometimes spews out these huge masses of matter into space. We call these coronal mass ejections, or CMEs for short. CMEs contain plasma and embedded magnetic field. We're able to see parts of the sun where the magnetic field is all cattywampus, technical term, exhibited as sunspots. A recent sunspot, AR3664, was big enough to be seen with the naked eye, assuming you wore your eclipse glasses. This sunspot was incredibly active and kept farting out CMEs like it had a bean burrito from Taco Bell. This leads to a situation where multiple CMEs can end up conjoining to become more powerful. We refer to this as a cannibal CME. If one of these streams of particles ends up coming towards Earth, it ends up interacting with Earth's magnetic field. This field is referred to as the magnetosphere and acts as a protective barrier from the sun's ionizing radiation. While it's typically just dealing with the normal solar wind, during CMEs things get a little bit more exciting. If magnetic fields are correctly aligned, particles start streaming down towards Earth's atmosphere at the poles. These particles end up interacting with Earth's atmospheric particles, so nitrogen and oxygen. They get excited and then can't really hold on to the energy, so they spew out photons as a result. That is what we end up seeing as the light from the aurora. The geomagnetic storm that we had on May 10th ended up topping out this scale at G5, a K-index of 9. This map shows you basically the aurora oval that you can expect with a different degree of storm, and Acadia National Park, where I was headed, was right here. Okay, that's auroras in a nutshell. How about the photos? From Mount Desert Island, the aurora could be seen briefly after sunset, then were lost behind the clouds. Even while nearly overcast, there was a weird red glow to the sky. There was a brief but beautiful opening in the clouds for a short period, then it was cloudy for the rest of the night.
Good Lord, what is happening in there?
Aurora Borealis?
That's it?
No.
Clouds, right? But we weren't done yet. NOAA forecasters were saying the following day was going to end up being a G4 plus in intensity. Here's how chasing that down went. Special night tonight. We are in Acadia National Park and we are going to Jordan Pond. We're going to see hopefully some more aurora. Last night there was a spectacular showing around here, but it ended up being cloudy. I only ended up catching a short glimpse of the aurora last night. Tonight looks like clear skies. We'll see if the light show continues. Maybe we can capture something spectacular down at Jordan Pond. Here we are, Jordan Pond, Acadia National Park. We'll see if we're able to see aurora tonight. Last night was the strongest aurora we've seen in over 20 years because of a number of very intense solar flares forming what's called a cannibal solar flare. Tonight, it might end up persisting. What I was seeing before is that the storm is still going on at a K-index of 7 compared to yesterday's 9. It's not as intense, but still might be able to be visible. The sun's just about set. This is beautiful. About as peaceful as it comes out here. Might have to get a few pictures and see if I can find us a spot. Let's take one handheld real quick. Time to find a spot. I think this is gonna end up being my scene here. It's really beautiful. A few larger rocks in the foreground, with The lens is going to be super wide, so you won't particularly notice them. And hopefully the sky will be filled with fantastic aurora. We still have the blue light. I should probably end up getting an exposure, so if I want to end up pulling out that kind of detail a bit more, I have that option. So why take a photo during blue hour? My thinking was I'd be able to utilize the foreground from this image, then once the aurora started and I was taking shorter duration images, not capturing as much detail in the foreground, I would be able to blend two images together, making one seamless image with loads of detail. With that out of the way, I was able to go and do a bit more exploring. We'll see how the images end up turning out at first, if the auroras end up appearing, because I'm kind of liking this spot right here with this little pine tree. So we could always move over a little bit further, and that big rock that's over there, we're just about over there where that rock is. I'm getting excited. This is super cool. And now it was time for the waiting game. Temperatures plummeted pretty quickly in the evening. It ended up reaching about 40 degrees Fahrenheit, so pretty chilly. Most of my batteries were not doing well in these conditions. My microphone battery died, as well as my GoPro battery. The stars began to creep out, and I thought I got my first glimpse of the aurora just to the left of this pine tree, so I started taking pictures. Where I had thought I had seen aurora,
Nope, Chuck Testa.
just clouds. Or still, since I couldn't go back to the exact composition of the blue hour photo, this was no longer going to be of any use to me. Not to be dissuaded, I continued waiting, listened to the songs of the loons, and gradually started to notice a change in the horizon of my photos. It was faint, but the aurora had started to appear. There was a brief gust of wind and my equipment started to fog over. The aurora were weakening, so I started making my way from Jordan Pond north out of the park. At a pull-off next to Eagle Lake, I had to stop. The green glow from the northern lights was plainly visible on the horizon. The camera sensitivity is maxed out here, so there's a lot of film grain, but this is how it looked in real time. I tried to capture it here and it's a little bit difficult to make out, but you can see this sort of cascade of what looks like heat lightning moving across the northern lights. We saw this for a period and then they suddenly became way more intense. The aurora gradually faded, leaving me in awe of what I just saw. Fun check, fun check. Thanks for sticking around. We covered a lot of ground on this one with the nerd stuff, so if you want to read some more information on that, I'll put some links in the description. Otherwise, next video is going to end up being on more traveling around in Acadia National Park. If you want to check that out, be sure to subscribe. We'll see you next time. Curious about the next time there's going to be aurora? The Space Weather Prediction Center has a subscription service. There's a link on the bottom for that, and it's completely free. Be sure to sign up for it if you're interested.